Hello, my name is Paul, and this is my submission for CS50AI project PageRank, where we have implemented an AI um, that can carry out page rankings similar to the way that the Google PageRank algorithm works. And we've done that using two different ranking methods. The first one uses a random surfer model, where we essentially simulate a web user being dropped initially randomly onto one website, and then them either clicking links on their current websites to visit other websites, and there also being a small chance of them instead randomly selecting any website from the corpus of websites provided. And so by understanding that, we can develop a transition model for each website or state the user is currently in, and they can travel between these states in a way that's along the lines of a Markov chain. The second way that we're calculating the page rank is using a mathematical expression where we iteratively sort of refine the page ranks from an initial starting value down to a sort of minimum which is very close to their actual value under the ranking scheme. So in order to do this, I've implemented three of the functions in PageRank.py: the transition model, sample PageRank, and iterate PageRank functions. And so now we should be able to run through some of these sample corpus of pages that we've been given. So let's start with corpus 0, and if we run this, we get the result back quite quickly. So for the surf sample, the random surf sampling method, we are taking 10,000 samples, and from that we get this set of results for the ranking of each pages, and we can see that 2.html has the highest ranking at just under 50%, and that's actually because if we look in corpus 0, most of the pages, in fact I think all of the pages, 1.html, 3.html, and 4.html all point to 2, so there's a lot of possible connections from the other pages to 2.html that are sort of increasing its performance. And we can see that for the iteration method, we get fairly similar results to the sampling method, and it took 11 iterations to converge. And I've also just got a printout here to show that these page rankings for the corpus all do sum to 1, which makes sense. So because this is using random sampling, if I run this again, we will actually get slightly different results for the random sampling method. These results will always be the same because it's the result of a mathematical equation. So we can see that for our page ranking for 1.html has gone from 0.2245 to 0.2196. And the larger the sample size you choose, the less variability there will be in these results as your sample size gets bigger. But at the n equals 10,000 size, there is some definite variability in the results you'll get. So we can also do this for corpus 1. And here we can see that games.html is the highest page ranking page, and again the iterative results are very close to the sampling results. And finally we can do this for corpus 2, and we get a similar thing happening where, let's see which one's the largest here, programming.html, that looks like it's the highest ranking page, and again here, and wow, actually these have come out exactly the same, which shows that especially as your sampling gets larger, these numbers, the sampling method and the iteration method, will start to give you very, very similar results. So that's my submission for this project. Thank you very much for watching this.